Thank you, Amy. And it's a pleasure to be here with you today to tell you and share with you some of the things and obstacles that we faced in Texas as we dealt with a new drought of record in our state. Let me just start. Let me tell you a little bit about Wichita Falls first. Most of you probably don't realize where that's located in the great United States of America, but we are a north central Texas town. We serve a population of about 150,000 people. We have a population of 104,000 inside our municipal city limits, but we're also the regional water provider for 15 other wholesale water users in the North Texas area. We rely entirely on surface water. There is no groundwater in the North Texas area of any substantial quality or quantity. None. If you drill a well in the Wichita Falls area, you drill about 30 feet deep. You have water that's high in nitrates, high in chlorides, and if you can get 6 to 7 gallons a minute out of it, you've hit a gusher. There's no water in our area. We have 2 surface water supplies. We own 95,000 acre feet of water rights, and in Texas we deal with large volumes. We deal with acre feet. I hear you guys talk about thousands of gallons or millions of gallons up here, but acre feet is what we deal with in Texas. Lake Arrowhead and Lake Kickapoo are freshwater lakes, which means we can take that water directly from the lake and treat it by conventional treatment. Add some, splash some chlorine in it, and chloramines, add some flocculant, some coagulant, and then run it through sedimentation, filtration, and then hit it with another dose of disinfection to send it to the distribution system. And we'll also have a Lake Kemp, which is a brackish lake. There's salt water that seeps up out of the ground about 90 miles west of Wichita Falls, and that water winds up in Lake Kemp. So to treat that water, we have to have a microfiltration reverse osmosis plant, which we brought online in 2008. 66 MGD of conventional treatment capacity, 10 MGD of membrane treatment capacity. And as I said, we are the regional provider for 15 other wholesale customers. Well, how did we get in the situation we got into? The drought actually started in Texas in October of 2010. And in 2011, we typically averaged 28 days over 100 degrees for the whole year. 2011, we had 100 days over 100. That's over 3 months of over 100 degree temperature. And you know how devastating that can be on surface water supply. Every day in July was over 100, and every day but one in August was over 100 degrees. You couple that together with low precipitation, 28.5 inches of a typical annual rainfall. We had 13.5 inches of rain in 2011. Thank God our reservoirs were at 87% capacity when that drought started. And by the time we got through with that year, we were sitting somewhere around 50 to 55% capacity in our reservoirs. This is what Texas looked like in 2011. You'll notice the entire state is in some form of a drought, and almost 88% of it was an exceptional drought. The drought improved over the next 2 to 3 years, but right up there where Wichita Falls is, that little 2 or 3 county area was an exceptional drought all the way up until May of 2015. We never caught a break. The rest of the state came out of the drought some, but we never did. So what do you do if you're on surface water? When you have a drought, you implement your water conservation drought contingency plan, which we did. And this is just a timeline of it. It doesn't mean anything, but the important thing to note here is we were 1,395 days of water restrictions. 3 years and 300 days before we came out of water restrictions in Wichita Falls. And I tell you all this because I want you to understand what you got to get a feel for what our residents and wholesale customers are going through. Because if you understand that, you can better understand how we're able to implement a DPR project. Conservation took our normal everyday consumption from 35 MGD down to 11. That's pretty draconian water restrictions right there. So what did we do? We knew we couldn't conserve our way out of a drought, especially a new drought of record. Nobody knows how long the drought's going to last, but we knew 2011 was a monster. It was a bear. It was brutal, I'm telling you. It felt like we were living in an oven. So in 2012, staff internally, we began to revive an old reuse concept that had started back in 99 and 2000 during the last drought in Texas. We met with the Texas Commission on Environmental Quality, and in Texas, that's our, you guys have the DEP down here, it's the TCEQ in Texas. And we learned that they've come up with these new definitions for reuse, direct potable and indirect potable. And I think Dr. Stanford explained the difference between the two, and the same thing applies in Texas, except that indirect potable reuse has been going on in Texas for centuries. We as cities treat our wastewater, we discharge it into a river, it runs down the river, and someone picks it up downstream and uses it for drinking water. It's been going on for centuries. And now all of a sudden it's got a fancy new term called IPR. And guess what? Now there's new regulations for you to use that water. So anyway, we were able to identify the treatment levels which the TCEQ expected us to meet if we went DPR. We hired a consultant to evaluate a long-term supply, and internally, myself and my staff developed our emergency DPR project to get us through the drought. We had done a lot of testing of our River Road wastewater treatment, or wastewater effluent, for non-regulated contaminants and numerous other regulated contaminants. And what we found was our actual effluent, once it was through the wastewater treatment plant, met 94 of the 97 drinking water standards in Texas. It was almost drinking water when it was leaving the wastewater plant. The only thing we couldn't meet was the nitrates, trihalomethanes, and obviously the microbes, the Giardia and cryptoviruses. But we knew we could remove that through the water treatment process. We knew Big Spring had already done it on a lot smaller scale in Texas, and we knew about Namibia, Africa, or Namibia, where they were already doing it. So we didn't have any trouble with understanding and knowing that we had the right treatment systems in Wichita Falls. So we compiled an engineering report, basically described the project. We would build a temporary pump station and pipeline. We would convey 7.5 MGD of highly treated effluent from the RRWWTP, is the River Road Wastewater Treatment Plant, to our microfiltration reverse osmosis plant located at the Cypress Treatment Facility. We would treat the effluent through both membrane processes. We would then blend it on a 1-to-1 basis with raw lake water, treat the blended water one more time by conventional treatment. And in the engineering report, it also summarized each level of treatment through each process, so many log removal for sedimentation, so many log removal for microfiltration. It set up the monitoring system, the standard operating procedures, the alarms, the shutdowns, all that you heard Dr. Stanford talk about this morning was incorporated in our preliminary engineering report. He got a lot of that information from TCEQ it was all about our project. The testing frequency and that type stuff. This is a schematic of the treatment process. At the top is the River Road wastewater treatment. We splashed a little chlorine in there, and we wound up adding some ammonia as well for chloramines. Goes through the MF, brake tank, RO, UV. This is kind of interesting. We operated for the first 6 months without UV. We were approved to operate without UV, but the condition of the approval was if you operate longer than 6 months, you're no longer considered a temporary DPR project. You're going to be considered a permanent. So we had to install UV at another $1 million. But the first 6 months without the UV, the water was perfectly fine. It goes into the lagoon. We then blend it with our water from our reservoirs, and here's the conventional treatment process, and then into the distribution system. This is the route of the pipeline. It was 12.5 miles. And I don't know about Florida, but in Texas, it always seems like your wastewater treatment plant is on the opposite side of the city from your water treatment plant. But we were fortunate in the fact that we knew the DPR was temporary, and we had always planned on it being temporary. So we actually installed the pipeline on top of the ground because we intended to repurpose that pipeline for our IPR project, after we got our permit and the right-of-way and all that design done. We were fortunate that we have a large drainage system called Holiday Creek that basically comes from here all the way to Lake Wichita, which is a small recreational lake. And then there's this drainage channel that runs up behind the dam and around to Cypress. We already owned all that right away. So we were able to take the pipeline and just lay it in the bottom of this deep creek, strapped it down, tied it off, and we're able to connect the two plants. This is some of the HDPE pipe. This is the fusing process. All you engineers will notice that's a way too large a pipe for 7 MGD. It's a 32-inch diameter pipe, but as I said, we wanted to buy the pipe and repurpose it for the IPR project. So the overall project cost us about $9.5 million, but $6 million of that is pipe that we intend to recover, and we have recovered. So in essence, our DPR project only cost us $3.5 million. This is the chlorine contact basin at the River Road wastewater plant here. Here's the temporary pumps. Yeah, it snows in Wichita Falls a little bit. There's a little snow on the ground there. But we take it, picked it up there. This pump had a VFD drive on it. This is just a backup diesel pump that was there in case of an emergency. This is the sedimentation basin, or the clarifier ahead of the MFRO plant. There's the RO treatment process, or treatment plant. Here's the lagoon we discharged it into. This picture was taken while we were doing the full-scale verification. You can see that's a pretty small flow there, but you can also see how clean and pure the water looks. And this is the clarifier for the conventional treatment plant, the filtration before it goes in the distribution system. So in summary, we began construction of our DPR project in August of 2013. And we began 75 days of full-scale verification testing in January of 2014. We allowed 6 months to lay the pipe, but we did it in 3 because it wasn't raining. So we were fortunate. 75 days of full-scale verification where we monitored and tested the water at 42 different locations at different frequencies for different constituents throughout the treatment process. We compiled the data. It was a 6,000-page report of data that we submitted to TCQ, and then we received approval for utilization in June of 2014 and began pumping the water into the distribution system July of 2014. It added 5 MGD of supply, which basically, if you recall, our demand was already at 11, so replacing half of that with DPR water basically drove our supplied half of our demand. We took the DPR water and the conservation efforts reduced the demand on our reservoirs by 80% during the drought. But people were feeling the drought. So overall, we operated for a little over a year, conserved 1.8 billion gallons of water. We had no public protest or complaints, and in general acceptance of the water. When we stopped, we actually had people complain about the water because we stopped using the DPR. They liked the water that much. The water quality was that good that they could taste the difference. They could taste the salt was gone. And the reason we were so successful, I think, is because early on we engaged all the media outlets. We're a pretty small market in North Texas. We're the biggest town in North Texas between Dallas-Fort Worth and Oklahoma City. So we were able to engage the radio stations, the TV stations, the newspapers. We have our own cable channel, all of our Facebook, Twitter, all that stuff. We engaged those media, and they supported us. And early on, we engaged the medical and the educational profession. We have a small college in Wichita Falls, and we engaged the county health board, healthcare coalition. We engaged an infectious disease specialist, professor of chemistry, geosciences. We took a lot of these folks with us on a tour before we ever started. Took them to the headworks of the wastewater plant. And we walked up there, and I thought, this was a bad idea. I mean, you have doctors dressed kind of like me, they're dressed up. And you know how bad a headwork smells at a wastewater plant. But then again, I thought, you know what? It's a lot better to have them to know that now than to spend millions of dollars and have them protest and fight you later on. Let's be upfront with them now. Let's get them on board. We took them through the entire treatment process, both the wastewater and the MFRO plant. And when we got to the end, we said, that's what we plan to do. Can you guys get behind us and support us? And they said, absolutely. And we were able to engage them and produced a video that we put on our city website, and we put it out to all the local media because we didn't want it has a lot more credibility if you have a doctor or professor saying, don't worry about it, the water's safe to drink, instead of a public works director or someone from the bureaucrat from the city saying, don't worry about it, we're here to help, it'll be all right. And it went a long ways for us, I think. I think that was one of the major reasons we were able to be successful. And quite frankly, we didn't have any other options. Our backs were against the wall. So, our long-term plan is to implement an IPR project. In Texas, that requires a discharge permit, which we already have approved. It requires some improvements to the River Road wastewater treatment plant. We're going to add some filtration. We're going to add some nutrient removal at the wastewater treatment plant. And then it obviously requires construction of a pipeline and pump station. For all these reasons is the reason we didn't do IPR to start with. We knew it would take too long. Our projections for water, well, we were going to be out of water in 24 months in 2012. We didn't have time, but we knew we could implement. We had the treatment processes in for DPR. All we had to do was get the water to the treatment plant. We knew we could do that. So this is our long-term water supply management, or long-term plan. Both projects have been bid. We expect them to be completed in about 24 months, January of 2018. And it will add 8 to 16 MGD of supply. Our treatment plant right now, wastewater flows are averaging about 9.5 to 10 MGD. Well, if we were only permitted for 5 MGD at the DPR. And obviously you lose a lot of that water through your treatment process. You lose 25 to 30% through MF and RO. With IPR, we can capture the entire flow. Long term, and in conclusion, obviously, DPR was our short emergency supply. Worked great for us. It sustained the city through the new drought of record. And for our intermediate supply plan, we intend to develop the IPR project, which we think will be online in the next 18 to 24 months. And then we're also looking at possibly constructing a new surface water reservoir in Texas, in the North Texas area. And there is some groundwater outside of our area, but quite frankly, it's 200 to 300 miles from us. And it would just be too costly to try to bring that water into the Wichita Falls. And there's my contact info. And I look forward to your questions. Hopefully, that was a 50,000 foot view. I'm sure you guys have a lot more detailed questions. I'll be glad to share and answer any of those as they come up. Thank you.